Hi guys, the next topic in fuzzy sets is called as alpha cut. So what is alpha cut? So alpha cut is a crisp set consisting of those elements of F which belong to fuzzy set to at least the degree of alpha. So what do I mean by this? This definition I don't think will help you understand a lot. So let us try understanding this with the help of an example. So initially we have a fuzzy set like this. So it has a few elements and then there are membership values associated to them. Now, what is an alpha cut with respect to this? First of all, we need to define a value called alpha. So let us say I define a value of alpha as 0.4. Now, how would an alpha cut set look like? Now, alpha cut set, in this case, since my alpha value is 0.4, is defined by 0.4 subscript old as 20, 0, 30, 0, 40, 1 and 50, 1. Now why do I have zeros and ones as the only membership values? So alpha cut sets, what they do is they take in only those values of only those elements whose membership values are greater than. So your mu should be greater than or equal to alpha. So only in those cases our original values in our fuzzy set can go into this alpha cut set. So clearly, since the membership values are only zeros and ones, you can also rewrite it as something like this. So this is no longer a fuzzy set, it is clearly a crisp set. So what does alpha cut actually do here? It helps us convert a fuzzy set into a crisp set. There is a small property associated with this. So if we have a couple of alpha values, alpha 1 and is less than alpha 2, and then you are supposed to be like coming up with two alpha cut sets associated with them. This is what would be happening. Now why is this happening? I'll give you guys a moment to understand this. Alright, so since alpha 1 is less than alpha 2, now alpha 2 would obviously be having less elements when compared to alpha 1. So that is the reason alpha 2 F would always be a subset of alpha 1 F. Now why are we using these alpha cut sets? I already told you that it helps us convert a fuzzy set into a crisp set. Now why is that useful? Because in the case of fuzzy sets, we had to like come up with new definitions for our operators. For plus, minus, union, intersection, we had to define them in a separate manner. What if we could convert our fuzzy sets into crisp sets? Because we know that all the operations were pretty much easy in the case of crisp sets. So that is why we are using these alpha cut sets. So let us try understanding this concept further. So I've given another small example here. So you use a universal set which has 4 elements in it, and then this is a fuzzy set which is present in that universal set. And what are the different alpha cuts possible in this case? Just 3 of them, one with respect to 0.1, one with respect to 0.3, and then the other with respect to 0.5. And these alpha cut sets, they can be converted into a special fuzzy set alpha raised to f for each x belong to u. So this is conversion of these crisp sets back to fuzzy sets. But then this is not the same fuzzy set as we have originally obtained. So this is not the same one as this. We are going to get some new fuzzy sets. So let us have a look at them. So this is a special fuzzy set 0.1 raised to f, and it is defined in a different manner. So how is this defined? So 0.1 subscript f is defined this way: x1, 0, x2, 1, x3, 1, x4, 1. So it is saying that all the values which have an alpha value greater than or equal to 0.1 are x2, x3 and x4. Now what is this special fuzzy set saying? Okay, fine. I already know that these are the values which, these are the elements that have uh, membership values greater than or equal to 0.1. So right now, instead of assigning the entire 1 as its membership value, I will only assign 0.1 as its membership value. So that is the only part that is differing from this point and this one. Similarly, 0.3f is defined in a same manner. So here we have 1 and then that would be replaced by 0.3 and then 0.3. And last one is over here. So over here we just have 1 at x4. So we'll be replacing that by 0.5. So these are the special fuzzy sets that we could like come up with our own alpha cut sets. Now let us look at the small part over here. This last part, let me try marking it. Okay, this one. So what does it say? Now if you were to get back your original fuzzy set from these special fuzzy sets, what would you have to do? All you have to do is make a union of them. If you just combine all of these three fuzzy sets, you'll be getting the original fuzzy set. So what you could be doing is, if you were to like perform any operation like plus, minus, multiplication or division, you could convert your original fuzzy set into something like this and then perform any operation that you want to, and then you could convert that value back into these ones and then perform a union of that, and then you'd be finally getting the answer. So this is equivalent to what you would be doing in the case of your new definitions for operators in the case of fuzzy sets. So that is all about fuzzy sets. The next topic we will be dealing with in fuzzy sets is called as multi-valued logic. So as the name suggests, this is a logical system in which there are more than two truth values. So in our traditional binary logical systems, we just had zeros and ones or false and truth. And in this case, so if you were like looking at a three valued logic system, you'd be having three values. So 0, half and 1. So you technically be dividing an entire section of 0 to 1 into three parts. So if you make it three parts, it will be 0, half and 1. And if you were to like ask me how a four valued logical system would look like, so you make it into four parts. So it is 0, 0 point, let's say 33, and then maybe you could have like 0.66 and let's say 1. So this would be a four valued system. So this is how you would be building your multi-valued logic. So these are the different combinations you'd be having for 0, half and 1. And with respect to that, this is what would be happening with an AND combination, an OR combination and an implication. Let us look at a few combinations here. So 0 and half would give you a 0. Half and half would give you a half. Half and 1 would give you a half. So technically this looks like an intersection between x and y. So sort of like minimum of x and y is what we're looking at in the case of three valued logic. Similarly, let us look at x or y. So 0 or half would give you half. Half or half would give you half. Half or 1 would give you 1. So this is sort of like union. So in this case, you're taking a maximum of x comma y. In the case of implication, with 0 and half, you'll be getting 1, because always remember, if you are starting off with false as your first argument in the case of implication, you would always be getting a true value. Half implies 0 would give you a half. Half implies half would give you 1. So what is this implying? So this is nothing but it is minimum of 1 comma 1 plus y minus x. So that is what we are looking at in the case of three valued logic. So if you were to like ask me what is the correspondence between logical and set operators, then I would say your union, as you have already seen, it is similar to your OR. Your intersection is similar to your AND. Subset is similar to your implication, and phi is similar to a 0 here. So this is what would be a correspondence between logical and set operators. Now, what's the link between multi-valued logic and fuzzy logic? Are they both the same ones? They technically are not. So what is the difference here? In the case of fuzzy logic, we use truth values in the range of 0 and 1. Now how many truth values do we have there? Infinite. We have infinite values within this range. But in the case of multi-valued logic, so if you were like talking about n-valued logic, we only have n discrete truth values. So we are not looking at infinite values. So that is the key difference between a multi-valued logic and a fuzzy logic.